t-test here in SPSS. You want to go to Analyze, Compare Means, Independent Samples, t-test. Bring over the box here. Expand it so we can see a little bit better. All right, so we have two independent groups, and then we're comparing these two independent groups on one outcome, one dependent variable. So on the Mad Libs lab, we wanted to see whether stats anxiety differed between the two sections, the two stat sections that we have. So stat sections is our predictor, our independent variable. We're seeing whether anxiety depends on whether you guys are in the first section or the second section. So our independent variable is going to go in the grouping variable box. And you have to click on Define Groups. When you click on Define Groups, you'll get this text box, or this prompt that says Specified Values. So here you're going to enter in your dummy codes for the different groups or categories for your independent variable. So remember, when we imported the data set, we dummy coded all our categories or groups using numerical codes. You want to enter those codes here. So we coded section 1 as 0 and section 2 as 1. So this is one of the reasons why you dummy code your categorical variables. If you enter the wrong dummy codes, the test will not run correctly. And then you want to enter your dependent variable in the test variable box. I know it would be easier if it just said dependent variable or outcome instead of test variable, but we're going to find our stats anxiety question. There we go. It's number 1. And we're going to bring that over. So stats anxiety, that's our outcome, that's our dependent variable. We're expecting that stats anxiety, or we're testing whether stats anxiety depends on what section you're in. So remember, we're testing whether the DV depends on the IV. Whether the IV predicts our DV. So you want to paste, and then run your syntax, and then you should get two tables, one with your descriptive statistics for your independent groups. So we have the n mean standard deviation for section 1, and then n mean and standard deviation for section 2. And then we get our independent samples t-test inferential stats. So remember, you want to look at your Levine's test for equality and variances. You want to make sure that this test is non-significant, that is, the p-value is greater than 0.05. The p-value is greater than 0.05, that means there is a non-significant difference between the standard deviations for our independent groups. So here our p-value is much greater than 0.05, it's almost 1. So we're going to use the equal variances assumed row here, because we're assuming the variances or standard deviations are equal. Now if the p-value is less than or equal to 0.05, then you would want to do the hand calculations that we discussed in class, similar to testing the equal cell size assumption. So once you check your Levine's test, then you can check out your t-value and your significance here. And then you also have your degrees of freedom. And then remember to calculate Cohen's d, the effect size for the mean difference between our independent groups. You want to go to the Line Morris website and enter the means, standard deviations, and n's for our independent groups. You cannot just compute the raw average between our standard deviations because our n's are unequal. So we have to give greater weight to the independent group with more people. So when we calculate S pool, our denominator, it'll be closer to the independent group with more people. So it should be closer to 1.43 in this case, section 1, which has 26 people. So that's the independent samples t-test.